Okay, so this is my first attempt at setting up as a validator on the Pangea testnet. I'm not a technical person. I don't really know much about code, but if the documentation is correct and if the documentation is good, then someone as dumb as me should be able to figure out how to do this. So let's give it a go. So where we're going to go is docs.harmony.1/validators. And there's a whole bunch of information to help us get set up. And there's also different cloud providers you can go with. There's AWS, there's Google Cloud, there's Vultr. They all kind of work in the same way. Some are cheaper than others. It's basically whatever your preference is. For this one, I'm going to go with AWS because I've actually used it before. And I have an account already, so that makes sense. But you might want to use Vultr. You might want to use Google Cloud. It should be the same kind of thing. So we're going to go to first time setup and look at the cloud guides and then AWS. So I already have my management console for AWS open. So we're just going to go through the instructions and see how simple this is. Launching your AWS node. If you don't already have an AWS account, register one. Okay, I have one. Once you are set up and logged into your AWS account, click on Services, Compute EC2. Okay. And then, oh, it looks a bit different, huh? Oh, well, they've changed the console. That's helpful. Oh, I have to let the guys know that their screen grabs are incorrect because AWS has changed the UI. Well, that's annoying, isn't it? Poor guys. I'm sorry, guys, but the button, which was blue, is now orange. Okay, well, it should be pretty straightforward. So I need to click on not the blue button, but the orange button called Launch Instance. Okay, so let's do that. And here we go. So now we're going to select the Amazon Linux 2 AMI HVM SSD volume type. That's number 1. Choose instance type T3 small. T3.small. There we go. T3.small. That's the one we want. Then next, configure instance details at the bottom right corner of the page. Okay, yes. Oh, what is all of this? Well, if I follow the instructions, I should be fine. Don't change anything. Next, click add storage at the bottom right corner of the page. Doing it. Yes. Shh. And change the size to 30. Done. Click next, add tags. Add tag, and then in the key input box, put name in value, put Pangea key. Name, Pangea -key. Click next, configure security group. All right, we're rocking and rolling. And on the default SSH port with port 22, change the source option to anywhere. Yes. Click add rule under type. Yep. Custom TCP rule. Yep. And under port range, put 6000. Okay. And under source, select anywhere. Okay. Click add rule, custom, TCP rule, port range 9000. Yep. And under source, select anywhere. Okay. That looks correct. Okay. Click review and launch, and then click launch. Ignore warnings such as your security group is open to the world, or your instance configuration is not eligible for the free tier. All right, I will. Consider yourself ignored. Click review and launch, and then click launch. Okay, we're launching. In the pop-up window, you'll need to create a new key pair. Select create a new key pair, and then enter a name that you like, for example, Pangea Key. That's easy enough. Okay. Click download key pair and save the key file somewhere you will remember. Okay, well that is a very long set of numbers. Okay. And where has that gone? It's gone as my downloads. All right. Let's have a look. What is that? pangeakey.pem.text. Okay. Good to know. Then click launch instances. Okay. Click view instances at the bottom right. Your new instance should be initializing. Wait for a few minutes for it to get started. Okay, it's initializing. Well, that wasn't so difficult, was it? Not difficult at all. So we're just going to wait for that to get properly initialized. Not sure how long it's going to take, but that is the first chunk of this done. Great. Pretty straightforward. Now, while it says the instance state is now running, so presumably I can now connect. So I need to open up terminal. It's easy enough. The first time you open up terminal, it can be a little scary because it's just code, but actually it's really straightforward. And if you follow the instructions, it should be fine. Once terminal is open, use the cd command to change your directory to where the key pair file Pangea that you. So I need to change it to cd downloads. Okay. cd downloads. Yep. And enter the command chmod pangea key.pem. No such file or directory. Okay. Let's check. Okay, change it to a .txt file. So we're going to change that extension. It'll say yes, I want to keep that. Okay, let's try that again. There's the command. And that appears to have worked now. There it says, no, on Mac, your PEM file may have been changed to a .txt file. So the correct command on Mac would be chmod 400 pangeakey.pem.text. Well, in fact, I just removed the extension on that, and that's fine. So now we go back to your AWS window where you're viewing your instance. Select your new Pangea Key instance and click connect on the top bar. Got it. In the pop-up window under the example header, copy the sample command to connect to your ES2 instance. The command will look something like SSHI, and there it is. Yep. Okay, we're going to copy that and paste it into the terminal window. It may ask you whether or not you want to continue connecting. Yes, we do. Type in yes and hit enter. Okay. And then we have to run the sudo yum update. Sudo yum! Always makes me laugh. Sumo yum. Sudo yummy. Sudo yum update. Yes, we wanna download that package. It's 38 megs. All good. All of this just to get set up. I'm sure there's a very clear reason for why we're doing all of this and what it all means, but to be honest, that is above my pay grade. So I'm happy just to wait for it to do its thing. Complete. Okay, so I'm going to do the sudo yum install tmux. Get that installed. Yes, please. And it's complete. So now we can do the command line interface. So that basically is AWS Setup, which is great. And that took all about 7 minutes to do that. So now we're going to move into the command line interface, and we have to download that first. And it's pretty simple. we just copy the code here, and the curl command downloads a file. So that's just going to download the Harmony CLI package. I think that's done. And then we're going to just paste in these lines of code. One more to go. And there we go. I'm just going to run the cookbook script to check that it worked. That looks good to me. That looks like everything is set up and running. So it's given me a list of commands of various things that I can do with the cookbook, which looks good. So yeah, we can move on to generating a BLS key. You will need to generate a BLS key in order to run a validating node. When generating a BLS key, the CLI will ask you to provide a passphrase to encrypt the BLS key file. So let's do it. So I need to enter a passphrase. Don't. Screen grab this. So now it's given me a public key, private key data. I'm going to copy that, put it in here. And now we can get into the next phase, so we can check which shard the BLS will validate on. So if you didn't know, in our sharded network, each shard kind of acts as its own network, and you'll be assigned to a specific shard, and that will become your home within the grander universe that is the Harmony blockchain. So we can copy that command, and then I have to make sure that I delete this BLS public key and copy and paste this, which should then tell us what shard we're on. Shard ID 0. Okay, great. So far, so good. Now we need to run the following command to download the node.sh script. Well, we can copy that. Here we go. Looking good. And now we need to create a new tmux session. Always used to run into problems with this before, but now that looks correct. And for any Debian-based OS like Ubuntu or others, please install the package below as it's required to run the node. I shouldn't need to do that because I don't think this is Debian-based. So now we run the nodes.sh script with the following command. And I'm going to paste that in here, and then I need to delete this and replace it with my public.key file. And that is doing its thing. And it's going to ask me for the passphrase for the BLS key file. Okay, staking mode, no key. It tells me I'm on shard 0. All looking good. Got some information here. Detach your node tmux session by pressing Control B. We do Control B D. No. There we go. Now I'm out. Okay. To check if your node is syncing properly, run the below command and check that the block height is greater than 0. Okay, let's try this. Block number 4330. And I'm looking for block height. Block hash. Block generally is at ID 0. I'll be honest, I don't actually know what I'm looking at here. So we're back in front of my computer and ready to pick this up again and finish it off. So, where were we? We were, yes, CD downloads. Yes, and now I need to copy that and log in. Yes. So I'm now connected to my node, my instance. And now I need to run the node script. Done. And now we are in the process of setting up a wallet. So in order to set up a wallet, I need to copy the new wallet CLI script. And I'm going to change this local account name to, always do that. I'm going to change it to supermassive. It's going to ask me to do passphrase. Repeat the passphrase. And now I have a seed phrase. So I need to copy that seed phrase and put it in a safe place. And it's also giving me a one address. So this one address I'm going to save as well, because I'm going to need that later on, I believe. So now it's saying, remember your passphrase. You will need to decrypt the account key store and also save your seed phrase somewhere as well in case you lose your key store. And now we can back up the key store file, and the command above will return the location of your account key store. You may want to create a backup of this file. So I can now copy that command and can I copy that command and paste it, and it will tell me where that file actually is on my instance. And we can also, what were we going to do? Just check that our node is running. So we've created a wallet, and we can check the balance, although we really have only just set up this wallet, so it's probably not that important. If you're not running a node, your node's not synced, use the following command to check the balance. Okay, so that's the one we need to use, because we are still quite early in this process. So I'm going to paste that in there and then copy my one address, delete this, and it gives me all the balances on the nodes in the different shards. So there are 0 tokens in those shard addresses at the moment, which is fine. That's what I expected. And now I'm going to create a validator. So in order to continue and create your validator, you will need to have 1 tokens in your shard 0 balance. To get tokens from our faucet smart contract, use the following command. Now this hopefully will work, but from what the guys at Pangea were telling me today, the faucet was down for the moment. So I might have to use a different method to get tokens in there. And let's see. If that worked. I'm now going to use this same command again to check the balances. And we seem to have killed it. Okay, well, I was kind of expecting that something would go wrong with that, because I had been warned. Okay, so we had a little snafu there, which was that the faucet that we need to get some testnet tokens isn't working right now, and the team is asleep because they're in the US, so I had to speak to one of the very nice people at Pangea to get some tokens. I have now got some tokens, and if we go into my balances here, I just did this, and I just call up the balances. It now tells me that I have 2,000 tokens in shard 0, which is exactly what I need to create a validator. So now I can move on to the final step, the important piece of all of this, creating a validator. So we go on the create a validator page. I now have the tokens I need on shard 0, so now it's the time to set up the validator. So I'm just going to go through and copy these scripts one by one. So we're getting to some interesting ones now. The max change rate and the max rate. So the max change rate is the maximum increase the validator can add to their commission rate. I'm just going to keep it at the default for now. The max rate is the maximum commission rate that the validator can set. And the min self-delegation is the minimum amount of stake the validator must delegate to itself. The max rate and the max change rate cannot be changed later. Well, that's fine for now. I guess there's some economics and some game theory involved in figuring those things out, but I'm just going to do that the way it has been for now. So basically that's it. That's the whole process of setting up a validator, and I found it challenging because I don't really know what I'm doing with the scripting process. But the guide was straightforward, and more importantly, when I did run into trouble, the guys at Pangea Ops, were able to help me out and talk me through what I was going wrong with. So it is possible, if you really don't have any knowledge of coding, you don't understand Linux and the commands, to set up a validator and get it running. Now, I still have to wait to see my own validator in the staking dashboard. Once I see that, I'll know that they've actually done the whole thing correctly. But in terms of the physical steps, the logical breakdown of getting from having nothing at all to an AWS account to getting the thing set up, it is doable for a noob like me. But you probably will want to have somebody from POps holding your hand through it. That would be what I would say. So I hope that was helpful. It's certainly an eye-opener for me, and it's important for me as well, as someone who's not from a technical background, to understand what's going on and to get some exposure to the coding part, to the technical part, to the networking part, and to be able to have those kind of conversations with POps. It's really good. And if you think that sending transactions on a blockchain is a really simple process, that's because the front end of it that you interact with has been designed in such a way to abstract away all of this complexity. And it's only when you start digging down and you become a validator and you start running a node and you see all the lines of code that you have to put in there and all the things, the processes that are actually running and the complexity of that, you suddenly have a much greater understanding of what it is that's going on and just what a dance it is to keep that thing running effectively. So yeah, hope that was useful, and I will get back with another video to explain what you do once you have a validator set up. But in terms of that, yeah, did it. Job done.